a course on embedded developments without any investment, because you can on PC develop an embedded system. And to conclude, I want to say that I2ST technology, this drag and drop concept, was awarded 2 weeks ago from the German Bitkom and the French counterpart, Syntec, as the best technology for embedded development. So you'll find more information on our website, the I2ST. You can find all technical information and the link to buy the evaluation versions of our products corresponding to real hardware targets. And on the edu.I2ST.com you will find this forum and the free simulator, which has no corresponding hardware target. We have some time for questions. Yes.
How do you simulate these buttons and all the peripheral things? How is this described? How is it available?
Oh, it's a picture, of course, and then we picture every button or every parameter, and we supply them in Eclipse as.
So you write the actual code for that, how the behavior of.
Yes,
of that. So.
But this is something you would do yourself. This simulator was done by a guy which is our legal manager, which is not a developer. I done that myself a part. I'm not a developer, so it's very easy.
Yeah, well, for button it's very easy, but for example, for this accelerometer, you have to specify the physical behavior, or.
Well, for this one, I think this was just a random X. Of course, for some devices, this would be more. Yeah.
So is it a hardware simulator? So do you actually execute the instruction set of the target processor?
Yes.
Okay. So it's a hardware emulator. Do you understand my?
No.
Okay. So does the simulator simulate like the Atmel part? Provide the instruction set? Could I run this assembler code, machine code against the? Okay.
No.
Okay. So it
provides the JVM.
Simulates the JVM. Okay. I wouldn't be happy as an embedded developer. I want to run in the target. So my environments, I prefer to run right directly in the target. So when I compile and run, I want to be able to run right in the target. Because then I can use the real buttons.
This is the conventional process.
No, that's an unconventional process, because usually you can't run in the target.
Yeah, of course. But if you want to see some physical demos, I have the
Yeah, you know, I actually have a piece of the hardware, but I was just trying to understand when you say, because emulator has many interpretations, right, or simulator.
Something I forgot to mention is there is a tool we do not yet have. It's a calibrator, because of course each PC will have different resources from another one. We guarantee 100% simulation of the target in terms of pixel and functionality. The only thing we don't have so far is the speed.
Yeah, I was to say, but you can't simulate clock speed, right? Or I/O response, or an external device, or okay.
But for the PC resource, we are working currently on a tool that will analyze the resource of your PC, and then you would calibrate your simulator in order to have the exact speed rendering. This is something.
Okay. I'll talk to Fred.
Yes.
Are there plans to rebase your virtual machine to real operating system, something like Linux or Windows, CD?
Well, something I did not mention is most of the time there is no need. The JVM includes an OS.
Yeah.
So it works bare metal.
Yes.
sometimes we work onto a proprietary OS in some cases for some customers. We working on developing JVM for integrity from Green Hills in order to address the Unix market. And we have a lot of demand for Linux. So
will it happen or?
It will happen.
Okay.
It will happen. You had also a question.
Can you tell us something about the real-time properties of the whole system? You told us about the code size.
Yeah.
I mean the response times to input changes, something like that.
Well, this is a field where I'm quite new. What I can say is one of our JVM is on real time. This is the one working in U-boats. And it is different from the others because the garbage collector is deterministic. And we reach response time in microseconds.
Perhaps you could compare the C performance with the, because you have some benchmarks. What's
yeah, the boot time is usually for this type of application you saw is less than 30-40 milliseconds, and the speed, execution speed, is similar to C. Well, I think for this graphical application, this was 95%. Is it? You know that?
I would say it's order 15%. So, within what a bad programmer can screw up, even if they're programming in C.
This was on the NXP. This was working on the 67 megahertz.
The typical problem is that object-oriented people don't understand how to do virtual machine programming for embedded devices, because most virtual machine programmers don't have any clue what's going on with the actual virtual machine. So it's typically often not the constraints of the virtual machine as much as the virtual machine.
They create too much garbage in their design.
Yeah.
And there's no collector.
Can't collect it fast enough.
No collector for design.
I thank you for your attention and.
There are some microcontrollers which have hardware support for Java.
Yes.
Are they supported by this language or?
No. This is something completely different.
I think you're referring to ARM.
Yes.
ARM just added, that's the name of the technology.
Oh, okay, but it's included in some hardware products.
There could be, but there are
Yeah,
a whole bunch of slides.